Hello again. All right, this is P07, the pulley wheel, acetal pulley wheel, and we're going to do a little tutorial on how we can go about modeling that. Let's jump across to the file we can download from Blackboard, being the drawing here. We can see it's called P07, and our description will be acetal pulley. It's a revolved section with a few ribs and then some fillets applied. So that's going to be pretty easy all round. The hardest bit's going to be sketching this profile and getting that fully defined. Remember, for full marks, you want all your sketches fully defined. A underdefined sketch will lose marks on the detail and appropriate use of SolidWorks area of the rubric. So we've got a 2-degree draft. We've got a few notes down here. 5mm wall thickness, meaning that this is 5mm thick, that's 5mm thick, that's 5mm thick. The only thing that's probably not going to be 5mm thick are the ribs, for reasons of drafting, which we went over in class, and the cooling of a tool. We don't like our ribs to be the same thickness as a wall. You can ask me about that in class if you want a bit more information around why we do that. And we also want to use fillets where appropriate. Again, there's reasons for tooling that we want to have fillets down the bottom. And then we are just going to sort of circular pattern all of this stuff and then do a mirror to get it across to the other side. So we'll do one rib, circular pattern it, mirror all that across. So let's begin with this sketch. We'll jump into SolidWorks, we'll create a new part, and we'll call it P07. Please keep your file naming nice and exactly the same way we're doing it in class. That is on the rubric, that your file names are all consistent with the convention that we decided upon in class, which is P07 for this part. And then from the property name, we will add description, and the description will be acetal pulley. Now, acetal is generally just a type of nylon. Acetal's probably the proper name for the plastic, while nylon would be a trade name owned by someone like DuPont. You could do a bit of research and prove me wrong if you want there. Acetal pulley wheel, was that the name? Remember, we want to get this exactly right. Acetal pulley. So that's good. We can hit OK. And let's start sketching this up. Now, we don't want to draw our origin at this point because we want a hole in the middle. So we're going to drop our origin down to here so that as we revolve that part, it makes the hole for us. So I'm going to draw on my front plane. Good old trusty front plane. We love a front plane sketch. And I'm going to draw a center line because that's what I want to revolve around. And I'm going to draw that across the bottom. Now I want that sort of fully defined, so I'm just going to make a midpoint relation between the origin and that line. And then I want to actually only sketch half of this profile and then mirror the other half. So let's have a look at that. Very good. So let's draw a vertical line here. We'll just draw it up here like so. And that's going to be our mirroring point. Very good. Now I'm panicking right now that I'm not screen recording, so we're just going to jump across to my little bit of software, and we are recording. Happy days. So let's jump back into the tutorial here. So I'm going to draw sort of half of that shape. I'll zoom in a bit because there's no use drawing from all the way out here if I don't have to. I'm going to come across, up. Now this one's got to be at an angle because we want that 2 degrees of draft on it, and then up again. That's enough for there, and I'll draw a little L up in this top section, something like that. And I'm just going to trim this down, probably somewhere about there. And I'm going to place a large arc across the top here. And I'm going to do another smaller arc just across the side there. Now the first dimension I'm going to put between those, see, I can drag and select. That's a pretty cool feature. We don't really go over that in class, but you can drag and select. If you drag from one direction, you'll only select what completely falls inside that box, like that. If you drag from the other direction, you'll just select everything that is in the box, even if it's only partially in the box, like those two larger curves there. Cool little fact, now you know. So I'm going to put a dimension between those two. I'm going to make it that 5mm wall thickness. And notice I'm just trying to get dimensions down as quick as possible. And just try get my sketch fully defined as quick as possible. There I'm using the center line. I'm pulling my dimension right across the other side so that I get that that full width. We'll do that again using these 2 dimensions, or 3. We'll do the 20, the 23, and the 25. So we have 20, and that's in the middle. So let's chuck that down. So I'm using the center line here. You'll notice the center line is selected, and that's what's allowing us to dimension to those imaginary points over the opposite side of our screen there. These 2 points here are what I'm talking about. There's nothing there. It's just guessing that we want it to be, across that center line. I believe that was 25, that final dimension, which it was. Very good. All right. So we can make that 25. We've got a few other dimensions. We know from our bush, if we looked at that section view, that this is going to be 13 millimeters, thereabouts. We know that most likely the thickest point of this area is going to be 5 millimeters because it's that 5 mil wall thickness. What else do we know? The midpoint of this line should be passing through the center point so that we get that nice even curvature. So let's make that a midpoint. And we know that that should be sitting more or less horizontally in line with the opposite side. So let's drop that in as well. Now we've got a few more dimensions. We could put our 12 mil radius across here. So I'll drop that in. That sounds like a good one to start locking in. And we also know that this angle should only be 2 degrees. So I'm just going to use a smart dimension between those 2 lines. When the lines are angular that you select, rather than doing a distance between them, it will automatically assume you're trying to dimension that angle. That's a peculiar sort of quirk of SolidWorks. I don't know why it does it, but we'll just drag that in so that we can actually see what we're working on. And finally, let's give it an outer dimension. We can see the outside diameter is 76 millimeters. So let's place a 76 mil diameter across the outside and that center line, and lo and behold, we're in a fully defined sketch almost. What's under defining it is the fact that that can move. To lock that down a bit, I'm just going to select the endpoint and I'm going to make it coincident with that line there. And we can see that's done a pretty good job of starting to lock it down a bit more. We're still apparently underdefined, so let's just click and drag on a few things and see what that effect has. We can see our other underdefined section is just here. So I might select those 2 endpoints and make them vertical. Now we're fully defined. Okay, one last thing to close up this sketch. We want to select all the outer edges. We don't want to select any edge that crosses the center plane. So that's being our top curve and our bottom horizontal line. We don't want to select those. But we'll select the whole outside. We'll select this center line and we're going to tell it to mirror entities. And now it's mirrored everything we selected across that construction line we had selected. So we're pretty happy. We're going to revolve that and we're going to start to see our pulley wheel taking a lot of shape. We've got 2 center lines here, so it's getting a bit confused about which one we want to revolve around. Under axis of revolution, we're just going to select that bottom line, and now you'll see what I mean by it creates that hole by creating the offset. So let's hit close and save on that. And I actually still want to see that original sketch because I want to draw something between it. So I'm going to right click and say show sketch. Okay, make sure it's showed. Don't start sketching in it again. Hit show. Now I'm going to create a new sketch. Remember, it has to be a new sketch on the front plane, being the same plane as my first sketch. I'll select normal 2. I'm going to zoom in and I'm going to just draw a single vertical line between those 2 edges there. That should be vertical. Mine's not, so I'm just going to select it and under relations, click add vertical. I want to dimension that position, so I'm going to dimension an offset between this sketch line there. And I'll make that about 2 mil. Feels right. It's not really dimensioned there, but we can see it's got a bit of an offset, and it's probably half the radius, and let's assume that radius is about 1 mil. So that's looking pretty good. That is all we need for a rib. So let's come across to our features. Select rib, and under our settings we're going to choose this one, which is both sides, meaning our rib comes out from both sides of our sketched line. We can see this arrow is telling us our rib's going to come out from our pulley wheel. We want it to go in, so I'm going to select flip material side. I'm also going to bring the thickness down from 10mm to 3mm, and I'm going to add 2 degrees of draft by clicking this to turn it on, changing that value to 2, and making sure draft outward is selected. If you're not sure what some of that's doing, just jump in. You can always hit right click and say edit feature, and you can change any of those settings at any time. If you just want to have a play around and explore it a little bit more, I would suggest you do that. It'll help you to understand what effect each of those dialog boxes is having, instead of just, I guess blindly copying what we do in class without putting in the time to understand why we're doing it. So now I'm going to choose circular pattern. That was from a drop down box under linear pattern there. First of all, I need to give it a parameter, something to revolve around. I'm going to grab this nice cylindrical face, meaning that it's got to be now revolved around the center of that. And under features, I just want to click that little edge there once. Very good. And now I've got 7 of those, like in the sketch. And I'm going to now select circular pattern and choose mirror, because I want to mirror that circular pattern across to the other side. And under mirror face plane, I'm going to drop down this little box here and select my right plane. Hit tick. And now we've got all of that on the other side as well. So I can hide that sketch. That's sort of finished being useful to me now. I'll hit save. And the final step on this is to add all of these fillets. So let's say they're 1mm. I'm going to grab my fillet tool. I'm going to set it to 1mm instead of 10mm there. And under items to fillet, I'm just going to select one edge, and I'm not going to move my mouse. By not moving my mouse, it gives time for this to show up. And what I want to actually select, in this case, instead of selecting 100 edges or whatever it is there, I'm going to select all edges, 177. There you go, it's quite a lot. And then I'm going to deselect the ones I don't want to fillet. That's just a lot quicker than selecting 177. It's a lot easier to get SolidWorks to automatically select them all, and then deselect the 4 or 6 edges you don't want. So the first ones we'll deselect. These ones we don't have to really hold any special hotkey, we just have to click on the ones we don't want, and a single click will deselect. A single click on the same line would then reselect it. We'll also move that, and I believe the final 2 to remove are this one on the front edge and the same edge on the opposite side. Now we actually don't have to orbit around, we can just click on that through our model, which is pretty snazzy, and that is hot to trot. So let's hit the tick to save and close those changes. It'll take a bit of time to think. That's looking pretty nice, I'm happy with that. The reason we have these fillets down the bottom is for the way the machine would typically cut the tooling. It would use a rounded ball bearing tipped type of tool. And we'll go over that a little bit in class. You can ask me about it again if you want more detail about, tool manufacturing and that kind of stuff. So we'll hit save. We can see it's P07. Let's just double check our custom properties. We can see it's set to Acetal Pulley. We can add our material. Remember, you're not really getting any grades on whether you've put the material in or not at this point, but it's just good practice for the future, so let's do it anyway. We'll hit material, okay. And then we want to select some type of nylon. Now we can't see one there, so if we hit edit material, we should be able to browse through a larger library. Here it is now. Just give it a few seconds to load like I did there. And under plastics, we'll go to a nylon 101, apply, and close. So now we can see that's set to nylon. Hit save. And you're done. You can close that. And you should be ready for class. We're going to start looking at assemblies in class. If you want to get a jump on that and sort of, make sure you're well and truly comfortable, there is a great section over in the design, in the home section at the side of your SolidWorks called tutorials. And these tutorials are fantastic. They're easy to follow. They're quite simple. I would advise you to come to getting started and look at lesson 2 assemblies. And then if that's sort of all very easy and simple for you, come across to basic techniques and have a look at assembly mates as well. Assembly mates will sort of just take it that next step further. Thank you very much. See you next Tuesday.